Welcome. In this video I'm going to show you how you can perform a Brunner Munzel test using Microsoft Excel. I have a separate video where I show you how you can do this with my StickPad-E add-in, which simply actually has a function for it, but in this video I'm going to show you if you don't want to use any functions. My data, as you can see, is in columns A and B, with in this case gender in columns A and the how motivated they were about something or what they thought about, how much mixture there was between number of activities and lecture, and that ranged from, as you can see here, far too little to far too much. I also put the categories just a simple number, and the first thing is to recode the scores to actually those numbers. So that's what I'm doing here. It simply is checking if both of these at least have something, and if so, then it's using a VLOOKUP in here and returns the second column. As you can see over here, must be an exact match. Note my system is using a semicolon to separate parameters. Yours might have to use a comma. Dollar signs around this table range so that it won't change if you copy paste it down, and then you can just copy paste this all the way down. The next thing is we need to split those scores in both the first and the second category. So if this one is the same as that one, then we use this score, and otherwise we don't use anything. We also need the so-called mid-ranks. For that we can simply use the rank average function of each of these. And we'll also later need the mid-ranks of the within versions. And last but not least, so-called placement values, which is the difference between this one and that one. So we have a lot of different ranks, but once we have all of those, we can actually get into the calculations. So that's been covered. So the first thing we're going to calculate is the variance of those placement values. So that's the variance of the last two columns that we made. Then we also need to know how many there were, so you can pick any of those columns to get that. In this case there were 11 females, 34 males and 45 in totals. Note I'm using the last two columns. Do not use the first one because it might be that some of these cases have, for example, here we have female but no score, so then we're actually not using it. So these exclude those already. We determine the estimated variance for each category. That's simply that one we just calculated over here and then divided over the grand total minus the category squared. So this one minus that one squared. And that's exactly what's being done here. We determine the overall estimated variance. So in this case, what we do is we use this formula. So it's this one divided by that, this divided by that, and then multiply, add those two, and then multiply by the grand total. Then the average of the overall ranks, so that's the averages of those within ones, as you can see, of these, but provided, so that's why it's average if this one matches that category. So similar here. So then we have the average mean rank, or average mean pooled rank. Finally, we can get to the test statistic, which is the difference between these two, and then divided by the square root of the total sample size, so that's 45 again, multiplied by that variance, so that one. And that's a matter of filling out the formula, and we get 4.46. Now you could use a normal distribution if the sample size is large enough. However, we can also use a t-distribution. For that we need this complicated formula. It looks more tricky than it is because we have everything. So it's just a matter of filling out that formula. This weird looking e is the uppercase sigma, which simply means to sum everything up. Once we've done that, then you get your degrees of freedom, and you can use the t-distribution to simply get the p-value. Note, however, that Excel will always round this degrees of freedom. So even if I would change this to 36, this doesn't actually change. And that's about it. So that's how you can get the p-value, which is probably the most interesting value of these. It's the probability of a result as in our sample, or more extreme if the assumption about the population would be true. In this case, the assumption about the population is a little bit tricky. It's not exactly that the medians would be the same for the two scores, but you can see it more like that. There is there's a good probability in this case that the two scores of the two groups won't actually be equal. So male and female are actually thinking differently about this. You could also do all of this with a cross table. So rather than just adding additional columns, you can actually create a cross table like this with just the counts. Determine the cumulative frequencies for each. So for the first row, that's simply the same. And then you just keep on adding. And then you can determine the within ranks fairly straightforward by just adding one to the cumulative one and the previous category. Yeah, and that should give you then the within ranks. The placement values are then of course the differences between the overall mid ranks and the within mid ranks. And once you have all of those, you can actually calculate the rest. Fairly straightforward. The means is a sum product of the original counts with the placement values, and then divide by again the total. So then we get these. Then we can determine the variances again. Similarly as before, so won't spend, you see the same formulas and also the same results. And we can determine the overall estimated one, the test statistic again, the degrees of freedom goes the same, and the final p-value as well. Alright, I hope this video was helpful, and thank you for watching.